CCI, Crash Course Instrumentation, presents episode number 25, Temperature and Flow Switches in the Wild. Goal: understand how temperature and flow switches work, where to use them, how to mount and commission them, and how set point versus reset, deadband prevents chatter. Credit: thank you to Tony Kuphaldt and the open source community for empowering Crash Course Instrumentation. Opening hook. If your cooler's low-flow alarm flickers or your heater trips early, it's probably not magic, just the wrong switch or the wrong install. Today we'll pick and place temperature and flow switches so they behave. Jargon decoder, used in this episode. Temperature switch, a discrete device that changes state when temperature crosses a set point. Styles include bimetal, capillary-filled bulb, and electronic. Bimetal, two metals bonded together that bend with heat. A small snap mechanism flips the contact. Filled bulb, capillary. A sealed bulb and tube push on a spring as the fluid inside expands with temperature. Excellent for remote sensing. Electronic temperature switch. Uses a sensor, like a thermistor, RTD, or thermocouple, and internal electronics to drive a relay or solid-state output. Flow switch. A discrete device that proves motion of fluid. Styles include paddle, thermal dispersion, and magnetic piston, sometimes called piston or vane. Deadband, differential. The gap between the trip point and the reset point so the switch doesn't chatter. Insertion length. For paddles, thermal. How far the sensing element projects into the stream. Temperature switches. How they work and where they shine. Bimetal snap. Simple over-temperature cutouts on motors, heaters, bearings, and enclosures. Fast response, compact, no power required to the sensor. Filled bulb capillary. Remote mount the switch head away from heat. Bulb straps onto a pipe or slips in a thermowell. Great when electronics would cook or when you need distance from the process. Electronic. Adjustable set point. Tight repeatability. Easy indication lights. Sometimes dual set points. Use where accuracy and flexibility matter. Mounting moves. Use good thermal contact. Grease on wells, firm strapping, no air gaps. Keep capillaries protected from kinks. For enclosures, place bimetals near the hot spot, not at the door. Common gotchas. Drafts or poor contact cause false trips. Long capillaries near hot piping drift. Electronic units need clean power and shielding. Flow switches, styles that actually work. Paddle. A hinged or spring-loaded blade in the pipe. Requires straight run upstream, downstream so flow is calm. Trim the paddle to pipe size per the manufacturer chart. Thermal dispersion. Two heated elements sense cooling from moving fluid. No moving parts. Great for clean liquids or air. Avoid coating service. Buildup insulates and slows response. Magnetic piston, inline. Flow pushes a tiny piston against a spring and a magnet trips a reed switch. Compact, repeatable. Watch viscosity and orientation. Where they fit. Proving cooling water as air to VFDs and drives. Pump run-dry protection. Lube oil flow interlocks. HVAC fan or airflow proof. Safety snapshot. Field Pro habits. On heaters, wire over temperature switches. Normally closed. In series with the contactor coil so a failed wire trips safe. On cooling circuits, treat low-flow proof as a permissive. No proof, no start. Add a bypass timer only if the system needs spin-up time. For paddle switches, add isolation valves and a union so you can service without draining the whole line. Selection, mounting, and commissioning tips. Temperature. Choose set points with margin. Set, deadband. Wide enough to avoid short cycling. Strap bulbs with metal bands and insulation over the top. Verify trip or reset with a heat gun or hot water and a meter on COM, NO, NC. Flow. Respect straight run. Typically 5 to 10 pipe diameters upstream, 3 to 5 downstream. Insert paddles to the manufacturer depth and trim to size. For thermal types, mount with the tip in the main stream, not a dead leg. Noise fixes. Add short input delays to ignore startup wiggles. For thermal units, clean the tip on a schedule. Documentation. Label set point and reset on the enclosure, plus date and tech initials. It's gold during audits. Tiny history moment. Bimetal thermostats powered early home and industrial controls long before digital controllers. Thermal flow switches rose with the microelectronics boom. Solid-state sensing that finally survived where paddles wore out. Takeaways. Temperature switches. Bimetal for simple cutouts. Filled bulb for remote sensing. Electronic for flexible set points and indication. Flow switches. Paddle needs straight run and trimming. Thermal has no moving parts. Magnetic piston is compact and repeatable. Deadband prevents chatter. Verify trip or reset during commissioning and write it down. Outro. Thanks again to Tony Kuphaldt and the open source community. Next up, Chapter 9 Capstone. Wiring, fail-safe strategy, and troubleshooting checklists that make discrete devices boringly reliable.